This example is from MGF 1107 and section 14.2 when we are discussing Euler paths and Euler circuits. And in this problem, they would like us to use Fleury's algorithm to determine Euler path. Now, an Euler path is a path, which means it doesn't necessarily have to be a circuit, but it's a path which traverses or uses all of the edges in the graph. Again, so since it's an Euler path or circuit, and Euler begins with E, maybe that can help you remember that it deals with the edges of the graph. Edge also begins with an E. So in this problem, we are given a graph over on the right-hand side. Looks like it has 9 vertices and a bunch of edges. And it's a multiple choice problem, but they want us to begin our path at vertex C. So C is right there. And what we want to do is create a path going from edge to vertex to edge to vertex, edge to vertex, and use all the edges in the graph exactly one time. So not more than one and not less than one time. So to do that, we can look at our options if we want. If you want to just trace all of these paths, you could do that. That's perfectly fine. One thing you should notice, though, is the last one cannot be the right answer because it goes from C then to vertex H, but there is no edge directly from C to H, so that one can be eliminated. But all the other ones, they go C, A, B, and you can number these as you go along if you'd like. Number the edges, C, A, B, and then back to C, then use this edge to D, and now from D, you could go a couple different ways. Now, one thing you wouldn't want to do, though, is according to Fleury's algorithm, you would not want to go to H, because then you're going to get stranded, because that's going to yield a disconnected graph. What Fleury's algorithm basically says is begin tracing your edges as you move through the graph and number them, as I have done, but consider them kind of like gone or invisible once you have gone over the edges. So kind of erase that from the graph once you've used it. So if you went to H at this point, you would have no way to get back to D because we're going to erase that edge DH. So we definitely do not want to go to H. And right away, since we don't want to go to H, you notice how they all start off as C, A, B, C, D, C, A, B, C, D, C, A, B, C, D. But these two go to H, and you don't want to go there, which means the answer must be the first one. But let's finish the problem. So we're at D, so we don't want to go to H, and you could either go to F or E at this point. So let's just say we go to E, and if you go to E, that's our 5th edge, and consider it gone now. And then after E, you only have one place to go, all the way to G. That's our 6th edge. And then to F is our 7th edge, and FD is our 8th edge. And now we can go up to H and then I. You notice this is an Euler path, since we used all the edges in the graph. It is not an Euler circuit, though, because we began at C and we ended at I. So this Euler path is not an Euler circuit. But they didn't ask for an Euler circuit. They only asked for an Euler path, and we gave them one using Fleury's algorithm.